This example is also another example of conservation angular momentum. On a spinning 100 kilogram disc with omega was 10 radians per second and radius 1 meter, I drop a 10 kilogram pellet on this rim. What is its new angular speed? So let's draw the situation. So the situation is as follows. I have a disc which is going to be rotating around in the counterclockwise direction at omega equals 10 radians per second. And I'm going to drop this pellet here onto this rim. So this is the initial state, all right? And then the final state is going to be you have a rim, a disc with a pellet on it, all right? Okay, so let's basically just draw what the and this radius here, sorry, is let's say 1 meter, all right? So let's write down the conservation of momentum equation. L1 initial plus L2 initial is equal to L1 final plus L2 final, right? So this is going to be spinning with some omega F, right? So this is just going to be equal to L1, well, sorry, I1 omega 1 initial plus I2 omega 2 initial is equal to I1 omega 1 final plus I2 omega 2 final. Okay? But because they're spinning together, that means that omega 1 F is equal, sorry, omega 1 F is equal to omega 2 F, which is equal to omega final. Alright, so this is just going to be equal omega 1 plus I1 plus I2 omega final. Alright, now this side is actually also pretty, so this pellet, which I'm going to drop on it, is initially not rotating. Alright, so let's call this number 1. Let's call it the disc number 2. So then that gives me basically I1 times 0 plus I2 is what? Well, that's just going to be 1/2 mr squared, m2r squared, okay, omega 2 initial, which is 10 radians a second. Alright, so plugging everything in, this is going to be 1/2 of what? 100 kilograms, 100 of r squared, r is 1 squared, omega 1 is 10. Alright, so it's going to be 50 times 1 times 10 is 500. Is equal to I1 plus I2. What is I1? Well, I2 we know that's just going to be basically 1/2 mr squared again. But I1, well, it's just going to be a mass, which is some distance r away from the center. So it's going to be basically m1, sorry, it's m2, times r squared. Alright, because it's the same r, omega f. So this is just going to be equal to 10 times 1 squared plus 1/2 times 100 times 1 squared again. So this here is, oops, let me just push that up a little bit. This entire thing here is just 60, all right? Omega f is equal to 500, okay? And that means that omega f is equal to 500 over 60 radians per second. Let's figure out what that is going to be. Let's break out the trusty calculator right here. 500 divided by 60. And that's equal to 8.3 radians per second. Okay, I hope that was very helpful.